Why you can't drink seawater. You're stranded. No boat, no land, just open ocean in every direction, all the way to the edge of the world. The sun is directly overhead, and it has not moved in hours. Your lips are cracking. Your throat feels like sandpaper. And all around you, in every direction you look, is water. Billions of tons of it. Cool, endless, lapping against the raft just inches from your hand. Every instinct in your body is screaming one word at you: drink. And that instinct, the most natural instinct you have, is the one thing that will kill you faster than the thirst itself. That's the part almost nobody understands. Seawater doesn't just fail to save you. It actively destroys you, faster than drinking nothing at all. Give a stranded person no water, and they last for days. Give them an ocean to drink from, and they die sooner. There is a hidden mechanism behind that. A kind of quiet cruelty built into your own biology. The very same system your body uses to keep you alive turns into the weapon that ends you the instant salt water hits your blood. To understand how, you have to forget everything you assume about why the ocean is undrinkable, because it's not the reason you think. First, you need to understand what your blood actually is, not just red liquid pumping through you. That's the surface of it. Your blood is a precisely balanced saltwater solution of its own. Everything dissolved in it, salt, sugar, minerals, is measured by a single number that scientists call osmolarity. It's just a way of counting how much stuff is crammed into the water. Human blood sits at around 300 units. It has to stay near there. Drift too far in either direction, and your cells start to fail. Now here's the number that matters. Seawater sits at nearly 1,000, roughly 3 times more concentrated than the fluid inside you. Hold on to that gap, 3 to 1, because that gap is the entire reason the ocean is a trap. Most people think the danger is obvious. It's salty. It tastes disgusting. So your body must reject it, spit it back, refuse to absorb it. That's not what happens. Your body doesn't reject seawater at all. It drinks it down, pulls it through your stomach and your intestines, and delivers every drop straight into your bloodstream, salt and all. The danger was never in the swallowing. The danger is what begins the moment it's inside you. Here's the mechanism, and it's beautifully, horribly simple. 1 liter of seawater carries about 35 grams of salt. The second it enters your blood becomes saltier than it is ever allowed to be. And your body has exactly one organ built to fix that: your kidneys. Picture them as a filtration plant working around the clock, but a plant with a hard, unbreakable limit stamped on the machinery. Your kidneys can only concentrate urine up to about 1,200 units. That sounds like more than enough to handle the salt. It isn't. Because a huge chunk of that capacity, around 600 units, is already spoken for, reserved every single day just to flush out urea, the ordinary waste your body makes by staying alive. Strip that away, and you're left with only about 600 units of real usable capacity to deal with the flood of salt you just swallowed. 600. Remember that number, because everything now hinges on it. Because when you drink 1 liter of seawater, you've just poured 1,000 units of salt into your blood, and your kidneys can only pack 600 of them into each liter of urine they produce. So do the arithmetic that your body is now forced to do. To flush out all the salt from that single liter you drank, your kidneys have to produce roughly 1.5 liters of urine. You drank 1. Your body spends 1.5, which means for every liter of ocean you swallow, you don't gain water. You lose over half a liter of it, pulled out of your own tissues and poured away, just to clean up the salt you were desperate enough to drink. And this is where the promise from the opening comes true. Seawater doesn't quench your thirst. It manufactures thirst. It reaches into your body, borrows your own kidneys, and uses them as the instrument of your dehydration. Every mouthful digs the hole deeper, and your cells are caught helplessly in the middle of it. Every cell you have is wrapped in a membrane that lets water flow through freely, but holds salt back. So, when the fluid surrounding your cells suddenly turns saltier than the fluid inside them, physics takes over, and water is dragged out of the cells to try to balance the two sides. Your cells begin to shrivel, and these aren't abstract cells in a textbook. They're the cells of your organs, your muscles, your brain. As the water drains out of your brain cells, confusion sets in. Then delirium. This is real, physical shrinkage happening inside your skull in real time, while you sit there feeling thirstier than you have ever been in your life. The scientists at NOAA put it in the bluntest terms they can. To get rid of the salt from a single drink of seawater, your body must expel more water than the drink gave you. So you dehydrate, and the more you drink to fight the thirst, the faster you dehydrate. You die of thirst, surrounded by an infinite supply of water, growing thirstier with every sip that was supposed to save you. You'd think that's the bottom of it. It isn't. Because your body isn't defenseless against salt. It has emergency systems, hormones that fire off desperate thirst signals and fight to regulate the sodium levels. The problem is scale. Those defenses were tuned over millions of years for the occasional salty meal, not for a direct assault 3 times more concentrated than your blood. Seawater doesn't sneak past your defenses. It bulldozes straight through them. That 600-unit ceiling isn't a setting that can be adjusted. It's a wall. No amount of willpower moves it. No trick of breathing or pacing yourself changes the math by a single drop. Every liter carries you closer to death, never further from it. And there is no version of this where the ocean wins you back. And this is not a thought experiment. This is written into the real history of the sea. For as long as people have been shipwrecked, physicians and survival researchers have identified drinking seawater as a documented cause of faster death among the lost and the castaway. And the reason is the cruelest twist of all. It's psychological. Out there, dying of thirst with water stretching to every horizon, the mind breaks. The delirium sets in, the reasoning collapses, and eventually the temptation wins. People drink. And in drinking the one thing that surrounds them, they seal their fate faster than the thirst ever would have alone. That's why the oldest survival advice at sea is brutally simple. Drink nothing, pray for rain, and wait. But never ever drink the water you're floating on. There's one last layer that most people never hear. Not every animal is trapped the way you are. Whales and seals drink seawater and live. Seabirds like albatrosses ride the open ocean for years, never touching fresh water, and they're fine. They didn't beat the math. They evolved around it. Marine mammals grew kidneys far more powerful than yours, able to produce urine saltier than the sea. Some seabirds grew specialized salt glands near their eyes that drip concentrated brine out of their bodies entirely, doing the exact job your kidneys physically cannot. You never got that gift. And the reason is almost poetic. For nearly all of human history, fresh water was somewhere within reach. A river, a spring, a rain. The ocean never had to select for that trait in us, so it never did. We are children of the freshwater world, dropped into a saltwater one, which brings you all the way back to where you started. You on the raft, the sun overhead, water in every direction, and not one drop of it yours to drink. Not because of the taste, not because of bacteria, but because of a single fixed number buried deep in the machinery of your own kidneys. 600, a ceiling you cannot raise, that quietly transforms the largest supply of water on Earth into a slow, precise, mathematically guaranteed way to die of thirst. The water was never your enemy. Your own body was.